welcome. The session today or this morning, and this happens to be what, your first breakout session for Tableau 16, right? Woo! So thank you very much for coming, and what a full crowd and packed we have here. So we're going to talk about understanding Tableau's order of operation for smarter analytics. My name is Kevin Emick, and I'm an enterprise sales consultant for Tableau, and I'm based in the great state of Michigan. And you know, the great thing about everyone from Michigan is we walk around with our map, right? So, anyways. You know, okay, I challenge anybody who's not from Michigan, make a map of your state with your hand. It's a little bit more difficult. What's that? Wisconsin. Well, yeah, you're the opposite. Okay, so anyways, I'm Kevin Emick, and this is my co-presenter, Tim. Go ahead, Tim.
Good morning, everyone. Tim Donch from tropical Cleveland, Ohio. Land of the Cavaliers, land of the RNC, land of number 2 in the Major League Baseball Association. I'll tell you what, by Game 7, we're all just, get it over with already. We can't stay up anymore. I've been an SC here at Tableau for about 4.5 years, and I've been working with this swarmy character in a couple different places over a long time. So without further ado, Kevin, take it away.
All right, thanks, Tim. Yeah, Tim and I have known each other probably, what, 15 years or so, and worked at a couple different companies together on the different teams. So I want to thank Tim for being here and being my co-presenter. All right, so what are we going to talk about today? We are going to talk about some of, we'll call it types of life orders. That's probably something like you'd see in Jeopardy, right? You know, that type of obtuse sort of label there. But then we're also going to, so we're going to talk about types of life orders. We're going to talk about the structured and unstructuredness of those. Then we're going to talk about Tableau's query pipeline. We're going to talk about what it is and why does it matter. Then we're going to talk about some common scenarios, and we're going to run through these in sort of a demonstration standpoint. We're going to talk about what's going on. We're going to talk about why is this happening, and then probably more important is what can you do about it. All right. So we walk into a restaurant, and we all know the drill. We get seated, and eventually the waitstaff comes up, and they say, "Can I start you with an appetizer?" And from there, they go on to the soup, and the salad, and then your main entree. But the great thing about going to a restaurant is that you can do it any way that you want. If you want to start off with your main entree first, and then you want to get your soup and maybe end up your meal with an appetizer, by all means, you can do that, right? A very unstructured environment. The only thing that's structured is hopefully in the back in the kitchen that they're making the food properly and putting all the ingredients together. But in addition, if you really wanted to, you could start off with that great cheesecake, right? And then you could move on to your main entree and then maybe into something else. Totally flexible. You have the ability to do it however you want. Now, on the far end of the other end of the spectrum, if you will, we have our good old dear Aunt Sally. How many people remember Aunt Sally? All right, yeah, so we're getting a few. Right, so it's, please excuse my dear Aunt Sally. It's a phrase that people came up with to help students remember how to do those mathematical calculations, right? So you have to follow a certain path. You have to, approach it very structured because there is an order of operations to doing mathematical calculations. You have to do everything in the parentheses first and your exponents, et cetera, et cetera, et cetera, right? And if you don't, you're going to end up with the wrong answer. So you can sit there and say, Kevin, why are you talking about food and getting us hungry before lunch? Or why are you making us think about mathematical equations at this early hour in the first session of TC16? Well, Tableau also has a structure to it. And we refer to this as the query pipeline. And in the query pipeline, we do it top-down. So the first thing you have is if you're doing an extract, you're going to do an extract filter. Right? I could have 20 years worth of data in my underlying database. I only want to extract out 5 years. So I can apply that filter, right? We're good to go. Well, then maybe after that, we also want to, if we're not using an extract, or even if we are, we could apply a data source filter, right? To thin that data set even further. Then we get into some things that you're actually going to do inside of your visualization and get the right answers. We have context filters. which would be the next thing in the query pipeline. And then we have some of those that you'll see off to the right-hand side. Those are operations that are done in parallel. So you have your sets, your conditional filters, your top-in, your fixed level of detail calculations. Then we come back into the pipeline. We apply our dimensional filters. Then once again, we go into a parallel operation where we do your include and your excludes to your level of detail calculations. You also do your simple aggregations. And this is where you also start to blend your data. So different than doing cross-data source joins, right, which was new in version 10. This is blending back in the workbook itself. Then we have our measure filters. Then once again, we pop out and we do some things in parallel. And those would be to compute your forecast, to compute the clustering, that's new in 10, and then also do those table calculations. Then we can move down the pipeline and apply any filters to those table calculations. And then finally, we'll have the trend lines, reference lines, and pages can all be displayed and computed. All right, so it all works top down. So as we're going through this, the challenge is going to be, what's happening and what can I do about it? All right, so before we get into that, I'm looking for shout-outs. What do these two things have in common? And for those of you who are not geography majors, that big red blob is the state of Iowa in the United States. It is another four-letter word, just like Ohio. Ooh. All right, so shout-outs. What do you think these two things might have in common? Corn? Okay. Oh, I guess I probably should explain. I probably shouldn't have to. The other image, that's what you're probably consuming every evening while you're here this week. Okay, so we got corn, right? So corn is grown in Iowa, and corn probably is used in the making of alcoholic beverages. Anything else? Any other thoughts? All right, I'll make it easy on you. So for today, the commonality is it happens just to be the data set that we are going to be using for the examples that we do. So we are going to be talking about what our friends in Iowa drink. So we may come in and say, all right, we have our list of products here and the amount of revenue that they're producing. Oh, let's see about this cinnamon whiskey, this Fireball. Who's drinking it? Or maybe we want the Grey Goose vodka. That's a little bit higher end. Or maybe we want to come in and say, in Iowa, in Johnson County, that happens to be the University of Iowa, the Hawkeyes, 30-some-odd thousand students there. What are they drinking? And so we can see that. Right, so this is just the only commonality, quite honestly, is the data set we're going to be using. All right, so during our session, I want to go and ask and answer some questions. So we're going to look at what are the top 10 products that are being sold in each city. Then we're going to build on that one and say not just the top 10 products, but they have to have a bottle price, average bottle price, greater than $15. Then I want to look at how can I find the average number of bottles sold per person, per county. And then we're going to finish up with some reference lines and some stuff that Tim's going to do there, and how do I look at the top 3 cities in each county, show reference lines for the overall average and the county averages. All right, and then each one of these we'll walk through on the query pipeline, what's happening and what can we do about it. All right. So our first question is, what are our top 10 products in each city? So here they are, that's the answer. Let's see if we can get to that answer. All right, so what I might want to do is come over and say, well, let's look at our total, and let's look at our description. Let's throw city in there also. Now I have a lot of data here, and I have a lot of cities. So what I want to do is let's focus on, all right, maybe just Iowa City. Let's see what those college students are doing. Okay, so we have that. Let's go ahead and swap that around. We'll go and sort it. All right, so now we just have a full list of everything that's being sold, right? sorted by the amount of revenue, but I want to see the top 10. So you say, well, that's easy. Let's just go and bring description over to your filter. Let's strap that on. We'll just pick a top 10 by total. And there we go. Is that right? Well, let's go back and look. So here it was before I applied the top 10 filter. Notice what our number 2 alcohol being served or being sold is, Jameson. All right, now let's look when I did my top 10. Jameson magically disappeared. All right, so let's go look at our query pipeline and see what's going on. So the first thing we did is we went and applied our top 10 by total, right? So we've told the data source, just give me the top 10 of everything. Then we said, now just filter for Iowa City. So you're filtering Iowa City just based on your top 10. And we really want it the other way around, right? We want to see what's in Iowa and then, or Iowa City, then give me my top 10. So knowing the query pipeline and that this is structured, I need to go and figure out how can I do that, living within the structuredness of this. So either I have to move my dimensional filter up the pipeline, right, get it up above my top 10, or put it at the same level as my top 10, or I need to move my top 10 below my dimensional filter. Okay. So Tableau has the concept of context filters. It's the ability to take a dimension and put it into context so that anything else lower down in the pipeline is going to automatically use that filter. So let's go and take a look at that. So you could add context, very simple, by just coming into your filtered item, say add to context, and Jameson's back. So let's take a look at what did we do. So we were able to take our dimensional filter, move it up the pipeline as a context filter. It then sorted just for Iowa City, and then we applied our top 10 to that. All right? So let's take that a step further. Whoops, didn't see that. Don't look at that. Okay, so here's our example 2. This is right where we just left off with number 1, but I want to take it a step further and say I want to see my top 10, but it has to have a bottle price, an average bottle price greater than $15. So you may say, oh, that's pretty easy to do. We have bottle price down here. We can bring it up to filters. We can say, let's show us our average. And we'll say $15. And we'll say, okay, let's go and actually, you know what, let's bring that up here. And so we certainly do have our bottle price greater than $15, but what happened? We, instead of having 10 records, we now just have 7. So let's take a look at the query pipeline to understand what's going on. So just like in example 1, we have our dimensional filter applied on your context for Iowa City. Then we did our top 10. Then we did our bottle price greater than 15. So it's only going to give us our greater than 15 from that top 10. Well, some of those aren't greater than 15. So we have to figure out, what can we do? Once again, we have 2 choices. We can move our top 10 down below our measure filter, or move our measure filter up. So Tableau, a while back, introduced fixed level of detail calculations. Those get executed in parallel along with that top 10. Well, I wonder if that'll fix it. Well, let's try that. Let's come in. Let's go and create a calculated field. We'll call this level of detail, average bottle price. And I'm going to cheat instead of typing all that out. But basically what we're saying here is I'm going to do a fixed level of detail calculation on city and description, and then give me the average bottle price. Right? So that will be one of the very first things that happens. So we'll say, okay. I'm going to pull off that. Let's pull this out. And let's use our level of detail. We'll put it up here. You know what, let's change that to average. And let's go ahead and put it in my filter. And we'll say, OK. Same answer. OK, well, let's try to figure out why. All right, so part of this example is to show that we failed, and failure by example. So the idea was that I was going to have my fixed level of detail calculation, which happened, pretty high up on the query pipeline, but we're using it as a measure. So yes, it was calculated up high, but it's going to be used down at a measure filter, so we're still at the same problem. So what else can we do? Well, is there a way that I can move my top N down below my measure filter? So Tableau has the idea of these table calcs. So maybe I can use the rank function in my table calc to do that. So let's try that. So we'll keep that. Let's go ahead and just make a copy of this. We'll turn it into a quick calc, do a rank on it. And tell you what, let's make that discrete. And we'll put it down here. Let's go ahead and get rid of that. And let's get rid of that. OK. So now I have my rank right down there, 1, 2, 3, 4, 5, et cetera, et cetera. And I have my bottle price and my total sales. But now I want to just get the top 10. So let's just drag this over. And we can just go ahead and easily select our 10. Or we could have it as a continuous and use the slider. Seeing as how I can't click all these. And we'll say OK. All right. Now we have one last thing to do. We aren't filtering by the average bottle price. So we need to get that up over $15. So we'll put that in your filter, average, greater than 15. OK. And there we go. So let's take a look at our pipeline and see what's happening. Right there. There. All right. So what I did was instead of doing the top 10, right, I moved that down as a table calculation. So it's below the measure filter. So we'll go and we'll do our context filter. We'll grab just Iowa City. Then we'll do greater than $15. Then I'll just say, give me the top 10, or in the rank, just pick the first 10. Now, we could also come in and remove the context. So we don't have to maintain context in there. And that's going to be a performance question that you're going to have to sort of look at on each of your use cases. Do I put it in context or not? Because there is a potential performance improvement or impact, depending on what you're doing and how much data you have and so forth. But regardless, you don't have to have it. We can remove it. And it doesn't change the answer. All right. Is that making sense? OK. Let's step it up a little bit. We now have our next question of, how do I find the average number of bottles sold per person per county? And then maybe we'll look at the top 3 counties, and then let's go ahead and possibly look at our percent of sales on these 2. So we'll come in, let's go ahead and just grab our counties, and we're looking at what? Bottle price? Bottles sold per person. OK, so let's put that on color. We'll change that to average. Let's go ahead and put it on label. Okay, so this is giving me the average bottles sold there, but not per person. I don't have my census data in this data source. But I do have it in another data source. I have it over here, and forgive me, it only goes to 2010, so we're off a little bit. But I looked, and there's not this big influx or exodus out of Iowa. It's been pretty steady and stable, so I think we'll be pretty good. All right, so what I want to do is let's go back and let's create a calculated field, and let's call this bottles per person. And we'll do a sum on bottle quantity divided by my 2010 population. And we'll say, OK, bottles per person. And let's go ahead and drop that one on color. And let me change my color back. And let's put that on label also. OK. So now what I want to do is draw your attention to a couple of what I would call anomalies. So one, this big blue spot down here, the lighter of the darker blues, that is Des Moines, Iowa. Anybody from Iowa here? All right. Your politicians drink a lot. That is the capital. It's in Polk County. And then we also have over here Johnson County. That's the University of Iowa and those Hawkeyes, and drinking a lot of that Hawkeye vodka probably. But what's really interesting is this space right up here, this Dickinson County. They are, when you look at it per person, 1.5 times more in that county buying alcohol than any other place in Iowa. So that's pretty maddening, right? If I'm sitting down in Des Moines, if I'm down here at the Capitol building and I see this, I might be saying, whoa, we got a problem. We need to go and dispatch all sorts of counselors up there. There's got to be this huge alcoholism problem. What is going on? Well, whoa, whoa, whoa. Let's just wait. Let's not let the government jump to any conclusions right yet. So went and started doing a little bit more research. And here is Dickinson County. You see anything that sort of stands out in Dickinson County? What's that? Recreational, right? Lots of lakes. So I actually did a little bit more research. So Dickinson County has 404 square miles. They're a pretty small county. And by actual land mass, they're the smallest in Iowa. They house or are home to 3 of the top 7 size lakes. So the hypothesis is, you know what, people like to go to lakes and they like to have fun and they like to party, and they probably don't bring their liquor from home there. They probably get there and get settled, and what do? They go out and buy their liquor, and then they party, party, party. So that could be the reason why they're having so much and so of an anomaly, if you will, or an outlier. Don't know. But that's sort of the hypothesis. OK. So we'll get back to our questions. So we want to know, what are our top 3 counties? OK. Well, we can probably simply do, what? Drag County onto our filter. And we had our top, and what do we call that? Bottles per person. Bottles per person. All right, that's not there. Well, why isn't that there? We created it. It's right here, bottles per person. Well, here's the pipeline again. Let's think about, we're doing a data blend to get our bottles per person, and a data blend doesn't happen until way down here in the pipeline. So trying to do a top in on something that doesn't exist yet, you can't do. OK. So let's think about, what else can we do? Well, we have this blended calculation here. So maybe I can bring that up, and let's do average. That's OK. what I really want to do is, we've seen this in the previous example, well, let's do a rank on it. And here, let's just pick our 3. Okay. All right. So that's showing us our top 3. And that's, once again, we just go back to our previous example where we did a table calculation using rank. But the idea here is that I can do it using a blended calculation. All right. So what I might also want to do is take this a little bit further. And we're looking at, and we want to do our percent of sales. So that's pretty easy, right? We can just grab sales, drop it on label, turn that into a table calculation, and do percent of total, and there we have it, right? Hover that over, it might be a little bit easier to see. So it shows 1.31% is what Dickinson County is. Okay, well, what if I just wanted to look at Dickinson County, let's do Polk and Johnson. And we just want to say, just keep those 3 counties. Well, what happened? Our number went from 1.31% to 4.44%. Okay, and that's because we're going to do the calculation based on just the available measures, or dimensions, dimensional values, and we have just 3 counties, so it's going to recalculate that. But I don't want it to recalculate, or best case is I want both numbers. Right, so how can I get that percent of sales and not have it change based on when I choose and I do filtering values? So let's take a look. Yes, we have a fixed level of detail. So let's take a look and see if that'll do it. Then we can come in, and we'll call this LOD percent of sales. And, no, I want 2. Oh, sorry. I'm trying to figure out. How about 4? Okay, there we go. I knew I had it pre-done. Okay, so the idea here is that I'm going to go and take a look at my sum of sales for my dimensional value that I'm at, and I'm going to divide that by the overall total sales. And that's what the squiggly lines are doing, right? That's your level of detail calculation. We can say, okay, let's go ahead and put that on the label also. Let's go ahead and drag our counties off. And let's go ahead and change our format here. Let's get a percent. Okay. So now we have Dickinson County. It shows us that our percent of sales is 1.31%. Our level of detail is 1.31%. But the idea is if I take and just say, well, let me see these particular counties and just keep those, that the numbers stay the same. And I don't have my maps turned on. So it maintained that value. All right, so let's take a look. Oops. Goodness. Okay. So in the query pipeline, once again, moving top down, we're able to do our level of detail calculation first in the pipeline. And then we did our county selection, right? Did our include, exclude, whatever we want there. And then we had our multiple data sources at the bottom. All right. Well, I'm going to turn it over to Tim, and Tim's going to take us home with some reference lines.
Woohoo, reference lines. All right, thank you, Kevin. All right, question number 4. So how do I look at the top 3 cities total in each county and show reference lines for the overall average or statewide average and then the county average? Well, this doesn't seem too difficult. let's start here with our total sales and look at our county. And then grab a reference line. And I'm going to do this on the table because I want that for all the data. And that's an average. Let's make this a little bit bigger so we can see it. Okay, so there is the overall average for all the counties. Let's break this out a little further and look at it by city as well. And we want an average for that as well, so we can grab another reference line. And this time I'm going to do it by pane. This can be a little bit confusing for newer people. So nomenclature-wise, the table is all the data, and then the pane is each county. So you can see there's a dividing line in between here. So each one of these counties is a pane. So this is going to give me my cities within the county. And a second reference line there. Let's make this one a little easier to see as well. Okay, well, that doesn't seem too tough. I've got an overall average. It's a constant all the way through the state there, 961,000. And I've got an average by county. What's the big deal? Oh, yeah, we've got to do our top 3 yet. So what we might do is maybe something like a top-end filter. Seems simple enough. Wrong answer. It only gave us top 3 cities. Why is that? Let's try something else. What if we wanted to do perhaps a rank? Okay. Now, over this weekend, a couple of my fingers on my left hand had a debate with a hammer, and the hammer won. So rather than forcing you to endure the pain of my trying to type, I've painstakingly, and I underline pain, put these in here ahead of time. So rank is just a usual Tableau function. It's the 1 through n, and we're going to take our total sales and rank that. All right, fair enough. Let's bring that down here. Now this is doing something interesting. It's ranked all the cities, but notice they're not quite in the order that we want. All right, they're 1, the first, second in the next county, third in the next county down. And I see this little triangle here on that rank that says this is a table calculation. So here's where we get back into that table, pane, cell business. And I want to compute this using pane across and down. In other words, start at the county and rank them within the county, then go to the next county and rank all those in the next county and so on. That's a little better. 1, 2, 3, 4, 5 by county, then it restarts. So it's breaking and restarting on county. Okay, great. Now, if I do my top 3, what's going to happen? Again, we might try that filter, take that out, and say, I want my top 3. Ooh, what happened? My reference lines just jumped around. Well, let's go over to that query pipeline again and see what's happening. So again, this is the order of evaluation. We did our rank, our 1, 2, 3, 4, 5, and our reference lines are down here at the bottom. So when I applied that rank, that was calculated first, and then the reference lines were calculated. So what happened was, remember those reference lines are averages, the statewide average and the county average. So first, I was averaging all the cities in the county and all the counties in the state. And then when I switched to top 3, it said, now take the average of the 3 cities in each county and the average of those 3 cities in each county and all the counties in the state. So that's why those reference lines jump down. So as you've already seen, the solution then is to take these reference lines, that calculation, and move this up here somewhere so it gets evaluated sooner. And looking at things like sets, conditional filters, they probably don't meet our need. I think level of detail calculations will come to the rescue again. All right. So let's take this out of here. And let's get rid of our average reference lines. And again, I've got a couple level detail calculations prepared for you here. So how are these evaluated? First of all, how many people in here are familiar with level of detail calcs? If you're not, if this seems like some mystic programming language or something, don't worry, there are 3 companion sessions on level of detail calcs in the conference this week. So again, what level of details do is say, calculate something at a particular level, hence the level of detail. So what I'm saying is, take my total sales by county and city and average it. Or we can go the other way. Take the average by county and city of my total sales. And this is for our overall. So let's grab this guy up here. And notice it's a constant bar. Well, we'd expect that. Remember the original line, 961,000? There it is. All right, it's going to be the same for every city all the way down. It's a constant line. Now, I'm doing it this way because this is kind of a standard problem-solving, debugging technique where we do things one step at a time, see if it works, move on to the next step. Oftentimes, when people build visualizations, they'll go 6, 8, 10, 12 steps in here and not get the answer they want and go, what went wrong? I don't know, you did 12 steps. Where do we start untangling this Gordian knot? So what I like to do is go one step at a time, make sure I got the right answer, and move to the next one. So our next step then is the county average. Again, a level of detail calculation. Let's take a look at that one. Now, this part right here is what we just did. This is our county average. Give me the average by county and city of my total sales, and then break it at the county level. So first, sum it all up or average it all up, and then break it at the county. So we'll bring this guy out here. And to make it a little bit easier to see, let's put that on color momentarily. Okay? So now I've got, you can see it broken by county. And let's bring our rank back out here as well and get our top 3. Okay, now we're getting someplace. All right. Now what this has done for us, I'll take this color off, is we now have our numbers correct, but how do we get to that reference line format? This is where we get into a little bit of formatting trickery. So we'll take off these individual calculations, and we'll bring up our measure values. Now, we got all these measures here. We don't want them all. We really only want those 2 level details. So here, let's filter those out and say only the ones that I was looking for. Okay, and then it's now a matter of formatting this. So we'll make this a dual axis chart. Ooh, what happened to my bars? Not an issue, because when we use measure values and measure names, it's given us some things that we can format. You may not have noticed, but here was our sum total, and here's our measure values, and we can format those. For example, with our total, we can force this back to a bar chart, like so. And then we can go to our measure values. If the dots, if we like those, that's fine. Or make them squares. In our case, we wanted them as lines. So there we have our lines. And that's all there is to it. So let's go to our query pipeline.
Quick question.
Yes?
Back. Why wasn't it on the first thing? Why the green line?
Oh, great question. One last thing to do here. Look at the axes. 26 million here, 3 million there. Let's just synchronize this, and now they're where they should be. Okay, so what happened there in the query pipeline? What we did was we took our reference lines and we changed that from a reference line calculation to a level of detail calculation. We did one for the overall level of detail, and then we did the county. Those got evaluated first, and then we did our ranking. And that's how we got to there. All right? Okay, so we've seen 4 examples here where the order of operations matter. Sometimes something different helps cement it in our memory.
We have to get on, we have to get on. We have so much time and so little to do. Strike that. Reverse it. This way, please.
See if you remember this classic.
There's only one caveat. The guy who runs the place is a little temperamental, especially about the ordering procedure. He's secretly referred to as the soup Nazi.
Why? What happens if you don't order right?
He yells and you don't get your soup.
What?
Just follow the ordering procedure and you will be fine. All right, let's go over that.
Words to live by.
As you walk in the place, move immediately to your right. Medium turkey chili. Medium crab bisque. I didn't get any bread. Just forget it. Let it go. Excuse me. I think you forgot my bread.
Bread, $2 extra.
$2? What do you want in front of me? Got free bread.
You want bread?
Yes, please.
$3. Nothing for you.
So as Kevin said, at a restaurant, you can order just about any way you like. But if you're doing math, or creating Tableau visualizations, or even ordering soup, the order of operations matter. Okay, so as I mentioned, there are some related sessions on level detail calcs, and this one will be repeated as well. And as you will be continually done throughout the sessions, please use your app and provide feedback for this one. Thank you very much.